Welcome. This is only 15 minutes, and I've got like 20 minutes to program something. We need to hurry. I'm going to talk about the REPL. Most of you probably have heard about the REPL. Hands? Yeah. It's a new feature in Java 9. And in my opinion, it didn't get as much attention as it should. That's why I sent in a paper to do a talk on the REPL. Afterwards, I learned that Robert Field, who's actually he's actually working on the REPL, is here. He's doing a conference session. So I'm going to treat this like an Ignite session to just show you guys how it works. And if you really want to know how it works, go to his session. Oh, there he is. So my idea, first, for the people who don't know what the REPL is, it's a read, evaluate, print loop. That's it. Since last week, it's available in the general JDK 9 build. If you download the early access build, the REPL is actually in there. I'm still using my own custom build version because I didn't want to change anything last minute. But if you go to that link, you download the latest early release of JDK 9, you can play with it. It's there. Let's do some live coding. This is actually what I want to make in 15 minutes. It's a fractal, and it's called the Sierpinski triangle. What you do is you make a triangle, then you create 3 triangles out of the first triangle, and then you go deeper. So let's stop the slides. Where are we? Okay. Let's go. We have to go into to my own custom build. It's JDK 9 build. JDK. If you go to the bin directory, where normally your Java is located, you see all those new commands like JDEPs. You should try that as well. And somewhere there is JShell. We can just start it. What you get when you start JShell is like nothing. You only get a prompt. And sometimes if you print stuff, the prompt gets in the way, so I usually turn the prompt off. And now you can just write Java. So for example, if we do system out println, we can say hello world. And it prints out hello world. The up arrow, same as always. That's it. And you can do other stuff as well. For example, we all know that tau is better than pi. So we can define tau by doing pi times 2. Now it says you have a variable named tau, which is a double 628, etc. And we can use that, for example, to print, because printing is very important. We can print tau. This is basically how it works. You don't have to start with a public static void main. You don't have to make a class. You can just write Java and it runs. So it's perfect for scripting, but also for prototyping. And that's actually what I wanted to do today, prototyping. To make it easy, I decided to use Swing, because that's like way cooler than JavaFX, because it's nostalgic or something. Let's make a frame. Oh no, it doesn't know JFrame. When you start it up, it only knows the Java base classes. So it knows mat because that's in the base package. So we need to import. But you can just write an import script. There we go. We've imported Swing. And we're going to need AWT as well. .star. And now, if we run this again, it actually makes a frame. So somewhere in the JVM, there's a frame. We can actually make it visible. And it should pop up somewhere, of course, on the other screen. There it is. That's our JFrame. And it's running live. And we can interact with this JFrame. For example, if I want to do, I could put a button on it. That's not what I'm going to do. I'm actually going to make a jpanel. Panel p jpanel. And I'm going to override the paint component method. So we make public void paint component. And it takes a graphic fix. And let's call a method named, well, let's don't do anything at the moment. And now we can say frame. We add the panel, which is called P. And it has been added to our frame. Well, you can't see this, but because we don't do anything in the paint component yet. But it's going to change. The next thing we're going to do is to actually do something inside the paint component, because we actually want to see something. So first I'll make a method called draw. You can also make methods. So this is a method that's not bound to a class, but it's bound to the REPL itself. So we make a draw method. It takes the graphic, width, and height. And let's just don't do anything. So we've created a method. If you want to see what we've created, we can use the /vars to see all the variables we've created. You can use /methods to view all the methods we've created. So we have a panel that doesn't do anything. We have a draw method that doesn't do anything. So that's kind of worthless. So let's edit P, our panel. When you call this, and it's on the other screen, you get a small editor. This editor allows you to see the previously created variables and methods and classes, and you can edit them, and you can push accept, and it gets loaded into the REPL. So this makes it just a little bit easier to edit stuff. I doubt you can read that, but that's probably better. So what we can do now, we can call draw, get width, get height. And we can push accept. And now it says you've modified the variable P. Yeah, that's it. Now we're going to edit the draw method and actually do something. So let's edit draw. There's the method draw. And let's say we're going to do draw an oval, for example, just to show something. Width. Yeah, that looks okay. Accept. So now when we repaint this component, which is still here, we should see a circle or an ellipse. So while this code is running, we're able to change methods, we're able to change variables, and we can prototype stuff. So let's go back to the example. This is what I want to make. So we have to start out with making a triangle. This is not a triangle. So let's edit the draw method again. Wait, there it is. For this triangle, we'll need 3 points. So we can make this. The first point is actually located on the top in the middle. So it's width divided by 2, and it's on the top. The second point is all the way in the bottom. So it's at, I don't know, 0, zero height. And the final point width and height. It's all the way in the other corner. And we'll say fill triangle with G, P1, P2, P3. So we've created 3 points, and we're calling the fill triangle method. And some of you might already have noticed we don't have a triangle, fill triangle method. So now it says you've updated the draw method, and you're referencing something that doesn't exist. You're referencing fill triangle, but it's okay. You can always make that. Just make sure you actually create it before you call the draw method. I'm not going to do that. Let's just resize this and call the method that doesn't exist yet. Yeah. You get exceptions. It's referencing something that doesn't exist. So we need to make a fill triangle. Triangle with the graphics object. Geez, graphics G. Point P1. Point. You know what? I'll just copy it from my cheat sheet. You're not here to watch me type. So, fill triangle. Now when we go to, where is it? There it is. Now it should fill the triangle. That's exactly what we need, right? The next thing we need is actually to create a fractal. To create a fractal, we have to take the triangle and divide it into 3 triangles. So we need a method to divide one line into the exact center, to get the exact center of the line. So that's why I have the mid function. You give it 2 points, you get the middle. So we can actually test this out. We can call mid with a new point at 0, 0, and we'll make another point at, I don't know, 2010. We get a new variable back, and it's stored as a temporary variable in $18. That's its temporary name. Actually, the name's not temporary. That's its name from now. And it's at 10 and 5. So we know our mid function is working. We've prototyped it, and it works. So what can we do now? Well, I'll just quickly show you the Sierpinski triangle. This is a recursive method. So it starts with void triangle. We give it a triangle and a depth. If the depth is 0, we call the fill triangle, just like before. And we return. When we have depth left, we divide the triangle into 3 new triangles. And we do that by using the top point and the 2 middles, the other point and the 2 middles, and the other point and the 2 middles. And we call it with depth -1. So it's recursive. And now when we edit the draw method, which is, it always pops up the other screen. Instead of calling fill triangle, we can actually call the Sierpinski triangle, and we can give it a depth, for example, 2. Now when we accept this, and we go to our running example, there it is. So this is our fractal. And we can actually, we can make it a little bit prettier by using a bit higher iteration depth, for example, 6. 6 should look good. And we can change our code while it's running. If we refresh now, there we have our fractal. Thank you. I've got a fan. But yeah, this is basically how you could use the REPL. It's a new tool. We don't know what we can do with this. They are working on an implementation of the Java REPL, the JShell, in NetBeans, for example. Other tools will get support for the REPL. And it has loads of other stuff which I didn't talk about. You can use the help function to see other stuff you can do. For example, you can export everything we just wrote, which is important if you want to save your work, because if I exit now, everything's gone. You can load scripts in. for example, I can see this being used as a scripting language using the new Java Files API. It will be easy to write your scripts in Java as well. That's easy because it's easier when everything's Java, right? Instead of shell scripting. Yeah, we don't know how it's going to be used, but if you want to know more, go to Robert Field's talk. He'll explain everything in depth. Time's up. And if you have questions, ask him.